Alright, in this section I'll be explaining the difference between shear stress and bearing stress. Now from the diagrams, these are probably some of the very clearest diagrams you can get. You can clearly see what the difference is, but again, I'll be going through and explaining this. So if a bolt joint fails, does the bolt snap or does it stretch out? Right, you can see. So these are two completely different failure modes. So I will explain clearly and briefly the difference between shear stress and bearing stress and why engineers must check for both. I'm going to try and make this simple, starting with shear stress. So shear stress happens when a force tries to make one part of the material to slide over the other, right? So now look at this like you have two parts, right? They're kind of sliding over the other, one going one direction, the other going the other direction. And so that's basically the effect of shear stress. So imagine like these are two plates bolted together, right? Now if you pull these plates in opposite direction, the plates actually want to slide. But then the reason you have these bolts here is to resist this sliding, trying to move. And then the bolt here is resisting that. But again, if the force is more than enough, it shatters, like you can see there. So if the force is high enough, the bolt gets to be cut across its cross section. This is shear failure in essence. Now, mathematically, we can see the formula here, right? Tau equals to force divided by area. Now, the area here is the cross-sectional area of the bolt. It's quite important to note that, and not the contact surface. Cross-sectional area, I'll write that. Cross-sectional area of the bolt. That's the area here. That's the area that's of interest. So shear tries to cut the bolt. Now, if you look at another example, very common one is scissors, like a scissors cutting paper, right? That's shear. A punch slicing metal, that's also shear, right? Okay. Now for bearing stress. Now, sometimes people get confused about them, but here the bolt isn't just resisting shear; it's also pressing against the sides of the hole. You can see. You see here, the sides are intact because it's moving this way and this way. But here, see this hole, right? So this contact creates bearing stress. So bearing stress is a compressive stress that develops between two surfaces in contact. Now, in this example here, the bolt is pressing into the sides of the plate hole. Now, if the force increases, the plate begins to deform, usually becoming oval, right? So you see, here's like you see this oval here. I mean, not a good failure mode for the engineer to look at, right? So if the force increases, the hole begins to deform, becomes oval. Now, you see the bolt might remain intact. Funny enough, you see this, it's intact. Compared to this one, both are shattered. So apparently this part will give way from this. But in this part here, I mean, integrity issues already at play. So this is bearing failure. Now you see the plate around the hole gets crushed or elongated. Now here the equation is also it's similar in the sense that here we have the force, but here instead of the area we have the diameter multiplied by the thickness. So here the D here is the bolt's diameter and T is the plate's thickness. Plate thickness. So now that's that's basically what it is. But in this case, okay, let me use this other diagram here. You can see the whole deformation bearing failure. That is the hole that deforms. But here is the bolt that shears off. Simple. The bolt shears off, splits, typically probably like at an angle. But for this one, see the hole is deformed and then there's some discontinuities in part. So integrity is then an issue of that part. So one simple way is shear tries to cut the bolt. That's what it tries to do. Just cut the bolt. But the bearing tries to crush the plate. Shear tries to cut the bolt, bearing tries to cut the plate. And that's as simple as it can get. So finally, just to summarize, so for shear, that's the force parallel to the surface, right? And failure mode is the bolt snapping, of course. Then the area that's affected is the bolt's cross-sectional area. But for bearing, it's the contact that is contact compressive force on it, right? Yeah, the hole deforms. But for the shear, the hole doesn't deform, but then the bolt itself snaps. And here's the diameter times the thickness that's that replaces the area typically when we want to find the bearing stress. I hope this helps in trying to make a difference and clear up any confusion with this. Thank you.